just a little bit about what Professor Schulte said just about the university as a whole, because it's important to understand not sort of the ecosystem in which you're going to be situated basically for the next 5 years if you come to Northeastern. So Northeastern, for the undergraduates, it's definitely on the not a small university. There are 19,000 undergraduates as of fall 2020, according to Wikipedia, checking just recently. And if you look at the graduate programs as a whole for the university, I assume these mean graduate programs on the central campus in Boston. As Professor Schulte said, there are satellite campuses elsewhere with various professional graduate programs, but I don't think these are being counted. There are roughly 8,600 graduate students, including both master's and PhD. So this is the, as a whole. And of course, very importantly, Northeastern is located, of course, in Boston. It's have the one downside of having this virtual open house, of course, that you can't come to the university to see the city, which is always great. Boston is, of course, a great, one of the sort of oldest cities in the United States, a really picturesque city. It's very kind of a good, I would say, medium-sized American city. And so Northeastern, so I have my little Google map here, to kind of show you the geography. As Professor Schulte said, here is Northeastern University. We're basically located in kind of the central Boston area. We're not effectively across the street from the main Museum of Fine Arts in Boston. We're not very far from the Boston Common. And you can see actually on this university also, one important thing to emphasize about Boston, of course, is Boston is one of these has one of the greatest, I would say, geographic clusterings of higher education in the United States. We're one of 5 or 6 top, I would say, research universities. And so in fact, just one of our neighbors is Boston University. That's effectively almost within walking distance, and certainly within walking distance, 45-minute walk over the river is MIT. And there's actually a lot, I'll talk about it later, there's a lot of sort of, just in the mathematical community, a lot of flow, I would say, between all the Boston area departments. So that's kind of an important feature, I would say, academically, that our department has, being by virtue of being situated in Boston, that we're not sort of situated as a single point somewhere off in the middle of the hinterlands, that we're actually part of a really big culture of mathematics extending beyond the university. I should also mention, if you're not familiar with Boston, one of the nice things I think about Boston is just it has a great public transportation system. So it's actually not really difficult to get around Boston, either by walking or taking the bus or the subway. This is kind of in contrast to a lot of other US cities. So that's actually a really nice feature. Okay, so this is just kind of very general about the university. About the department per se, well, let's see if my figures are roughly in line with Professor Schulte. So sort of the most relevant figure we have, I think, according to my count, depends a little bit on how you count, 31 tenure track faculty in the department. We'll talk a little bit more about the areas of math that these faculty represent. And then we also have 5 affiliate faculty who are in other departments but have a foot in mathematics. These faculty, I would say, typically come, I think they're all either from physics, and then they do some form of mathematical physics, or they do engineering, and so I would say some form of applied math. So we also have affiliate faculty in biology and computer science, but I think I counted actually them in the list of the 31. And so the important feature of these faculty right here is that these are all potential PhD advisors. And certainly, I'll just give you a general piece of advice. When you're looking at, you're all making choices about, a really important choice about where to do your PhD. And really the most important choice that goes into that, I would say, is who is going to be your PhD advisor, because the person you work with as your advisor really sets the direction of your mathematical research. Of course, as you get more mature, you have more experience, you can branch out from your original thesis research, but really the advisor typically sets the kind of thesis direction to a large extent. And so who you work with your advisor really has a really big effect. So when you're looking for, I would say, departments, you should always be in the back of your mind and choosing about departments, really think about choosing about what faculty member there you might be interested in working with, who's doing research in the area of specific topics that you think you might want to learn about, and really spend a big chunk of your 5 years diving into. So anyway, so we'll talk about the faculty in just a little bit. We also have, as Professor Shizzi mentioned, a postdoctoral program. Actually, yeah, I think I did the count. We have anywhere from, I would say, 6 to maybe 8 or 9 postdocs per year. I think I said 6 according to my count, right at the moment. It fluctuates a little bit. So we're very lucky to have, I would say, a thriving postdoctoral program. It's kind of maybe not so easy to appreciate when you're just coming from your undergraduate training, but really the postdocs are a vital resource when you're a PhD student, because they really serve as the link between the faculty and the PhD students. Oftentimes your advisor, your advisor is a faculty member. They're busy with all kinds of stuff involving the university, but the postdocs, they have a little bit less. They're really kind of in a transitional period between finishing their PhD versus moving on to a tenure track position, and so they may have a bit more time to really provide some mentorship, and they're a little bit closer in age to the PhD students, so they're a little bit, I don't know, maybe easier to relate to. So it's really actually great to have the postdocs around. I think they're really, in my experience, have been a very strong benefit to students in our department. We also have, as I say, the size of the program steady state would be 35 PhD students, fluctuates a little bit. And we also have a master's program. I think the figure I got was actually 76 master's students, according to the director. So roughly basically 2-to-1 ratio of master's students to PhD students. And our master's students are basically concentrated in areas of applied math. We have a master's in pure mathematics, which has a handful of students. And then most of these master's students are working on masters in applied mathematics or operation research. So I'd say, as far as if you're thinking about the size of our department, we're a medium-sized department. We're certainly not as big as a department like MIT over the river, but we're also not as small as some departments. We're roughly twice the size, I would say, Brandeis, for example, for a comparison. So we're a medium-sized department with basically a 1-1 ratio of PhD students to possible advisors. Okay, and so I guess one of the things, unfortunately, they're missing is a chance to see the Northeastern campus, but as a kind of poor man's substitute, what I have here is just a little map of the campus. And I guess the most important feature of the map, if you come to the university, is just where the math department is. So here's the math department. We're in a big complex of buildings, basically right in the center of campus, just off Huntington Avenue. I mean, one of the nice things I should mention about Northeastern is just that we are very well connected to public transportation. There are basically two individual subway stops on campus, so it's very easy to commute to campus. And we're sort of right across from the Museum of Fine Arts, right across from a nice Frederick Law Olmsted Design Garden, just down the street from the Symphony. So there's a whole lot of cultural activities that are just basically right off campus here. You should definitely, I would recommend, if you come to Northeastern, you're going to be so busy as a PhD student, but do not neglect taking, a little bit of time off from your studies to kind of enjoy things like, if you like arts or music or theater, things like that, to take a little bit of time to smell the roses. Okay, so that's just sort of a bare bones sketch of the math department. Now, as I said, the most important thing is really, I think, when choosing a department, is to think about who could advise you in the department. So here I have just a breakdown of these 31 tenure track faculty research areas. And this breakdown, I'd say, is pretty much arbitrary. Actually, it's interesting that Professor Schulze and I basically kind of had the same, I think, similar groupings here. And I'd say these groupings are not sort of hard, because many faculty members will work in linear combinations of these areas. Some people have feet in a lot of different areas. But as you see here, we have a very large group in areas of algebra and representation theory. And I would say this kind of spans commutative algebra, non-commutative algebra, representation theory of various sorts. So we have a big group of faculty in this area. And I would say this is one of the traditional strengths of the department. We're still, I think, very strong in this area. We have a good analysis PDE group. We have a growing, I would say, group of applied mathematicians with connections to biology, biology, computer science, for instance. We have a group in combinatorics, discrete math, graph theory, including Professor Schulte. We have a big group, I would say, of geometry and topology, broadly interpreted. I think this is both a strength of the department and also just a reflection of the fact that geometry and topology themselves in mathematics can be interpreted very broadly. So this includes differential geometry, algebraic topology, algebraic geometry, algebraic topology. So we have I would say, a very wide-ranging group of faculty in these areas. We also have faculty in mathematical physics, actually a quite sizable fraction for our department. And we also have a handful of affiliate faculty in physics who I could have also put in here, but did not. And then we have a reasonable group in probability and statistics as well. So I would say if you're just comparing our department to our, I would say, peer departments, as we say on this side of the river, so excluding Harvard and MIT, which are in a class of their own, I would say one of the features I think of our department, one of the good things about it is that we have actually strength in a lot of different areas. It's for a lot of our peer departments, they're kind of more focused in a few of these areas with similar sized faculty, but maybe a little bit stronger in some areas, not in others. But I think we have, I would say, a pretty good covering of all the bases as far as basically algebra analysis and geometry, the kind of core and kind of core areas of mathematics here. And hopefully, I should say, later in the day, I've tried to kind of give you, we'll have talks by various faculty, just to kind of give you a kind of a random survey of the work that's going on in our department in all of these areas here. Okay, so actually another way to think about sort of what goes on in the department, you can look at the list of the faculty and see what areas the faculty work in. But another way to think about what goes on in the department is just to look at the seminars that happen in the department. So the seminars are basically, kind of like how the analog of sort of the class when you become like a professional mathematician, a faculty member. The seminars basically function kind of like the classes, kind of like undergraduate classes. It's where of course you go to learn about kind of the most recent mathematics. And so I just pulled here kind of a list of regular weekly department seminars that we have, along with the web addresses. I'll share these slides later, so if you want to go and look at these seminar sites, you're more than welcome to do so, of course. So we have an applied math seminar. We have an analysis and geometry seminar. So this is like PDE, geometric analysis, differential geometry seminar. We have kind of a grab bag seminar on geometry, algebra, singularities, and combinatorics. I'd say this kind of really focuses on, commutative algebra, algebraic geometry, discrete math, combinatorics. We have a geometry, physics, and representation theory seminar. I should say this seminar I didn't write here, but this is actually a seminar affiliated with our RTG group. So we have an NSF-funded research training group in algebraic geometry and representation theory. And so this is a seminar affiliated with that. And so if you're interested in these areas of mathematics, I would say this is like a really great resource, because this is like sort of a formal group that kind of runs a lot of activities, conferences. This seminar, we run an undergraduate research experience, summer RU program for undergraduates in these areas that our graduate PhD students interact with as mentors. So this is kind of a really great thing we have. Also brings a lot of postdocs to the department in this area. The PhD students run their own seminar. So this is really a PhD student seminar. So that's a weekly seminar that they organize and run themselves. And I know faculty are not invited, so I've actually never been to this seminar, but they run this themselves by email. And I think it's basically kind of like a journal club. They read, they pick interesting articles in their kind of areas of research, and then give talks to their friends about the journal seminars. Our postdocs also run a really fun seminar. They call it the Pick My Brain seminar. It's a very informal seminar where basically you're kind of encouraged to ask kind of naive and off the wall questions of the speaker, who are typically other postdocs from the Boston area. So this is a lot of fun seminar. We have a tautology seminar that runs. We also have a colloquium, which we run jointly with Brandeis, Harvard, and MIT. And the sort of location, well, a lot of it's virtual now, but its location traditionally cycles between these universities. And I should say, as I mentioned before, we're sort of a member of at least a handful of strong mathematics departments in the area, all of which you can get to basically by the bus or by public transportation. So it's very easy if you want to like go to another seminar, say at MIT or at Harvard, or their conference or it's kind of a big workshop. These happen all the time, and it's very easy being at Northeastern just to kind of go as a graduate student. So it's kind of really great. I mean, even if Northeastern doesn't get the very biggest kind of speaker coming through, what maybe Harvard or MIT will, and you can go still easy enough to see their talks. So it's really kind of great. That's kind of a real perk about being in the areas. There are just so many, not only seminars in our department, but elsewhere in the Boston area. There are really too many seminars on top of all your classes, et cetera. Really too many seminars to go to. But it's really important. Going to seminars, I'll say in general, is really an important part of the life of a mathematician, kind of learning about kind of interesting questions, what's going on at the very forefront of a field, and it's kind of being a member of the culture. So the seminars in math are very important. Okay, so that's kind of some general stuff. Now, to kind of get to the nitty gritty about the structure of our PhD program, I think this is I think our program is, I would say, basically similar to a lot of other PhD programs. I don't think that the details here are really going to be a whole lot of difference between other programs, but let's just go through them here. So you saw in your admissions offer, all of our PhD students are guaranteed 8th-month academic year funding for 5 total years. So we have a 5-year program. The funding is just as usual, it's tuition and stipend, and we guarantee it to you from the start. So there does exist a limited amount of additional 2-month summer support, which is available through an application process. So I would say roughly half of the students apply for and receive summer funding. I mean, summer funding, we'll talk about it through basically being a teaching assistant for courses that run in the summer. And so some students aren't going to don't even really want to hang around in the summer on campus, but I would say roughly half of them do. And we typically fund them with an extra 2 months of support. And so we also provide funds. We have funds for PhD student attendance at summer schools. This is a competitive application, but we send at least 2 or 3 students every summer to the MSRI in Berkeley for various summer schools. And also students will, we try to fund students to attend workshops and conferences when they're a little bit further along in their PhD studies. So as I said, the funding in our department, most math PhD students are supported as teaching assistants, with a few each semester supported as research assistants. But typically, the typical expectation is that you'll be supported as a teaching assistant. So as we'll talk about, when you arrive in year 1, all of our teaching assistants receive training, basically through a weekly 1-hour course. So it's pretty informal, it just meets over lunch 1 day a week. It's run by one of our teaching faculty, Evan Dummett. And your duties as a TA, I would say they're typical. To start with, they start out kind of like, before you really had a lot of experience, basically you'll spend your time grading homeworks and exams for some undergraduate courses. And holding office hours and recitations. But eventually, we'd like to work you up. So of course, teaching is an important part of being an academic. Our goal is to eventually work up all the math PhD students to serve as instructor of record for at least 1 course before graduation. So serving as instructor of record means that you are basically the professor for that course. You give the lectures, you give the quizzes and the homeworks, you give the exams. Basically, you get to be to your students, Professor X. And this is typically for some undergraduate calculus course. So, the math is low level, but actually the teaching is pretty intense. Actually, you're the instructor of record. And that's actually really important. If you're interested in going further in academia and applying for postdocs, basically this is almost a requirement nowadays to find a postdoctoral appointment, is to have this kind of experience as an instructor of record, that you can actually are qualified to run a course, to run a calculus course run a calculus section. So this is just some bare bones here. So now about the requirements for the PhD program. Well, for the graduation, the kind of academic requirements, there are a total, I would say, of 8 to 16 courses required to complete the program. The number varies just depending on whether or not you're entering with a master's or just or an undergraduate degree. We have students coming from both places, and that's fine. The 16 courses would be if you enter just straight from an undergraduate. And if you already have a master's degree, that number can be decreased. Basically, you can get credit for your previous master coursework, potentially down to 8 courses. And you're required to register. You should register for at least 3 courses a semester. That's the typical course load, and maintain a running GPA of 3.0 in the courses. I would say that this, you shouldn't worry too much about. As a PhD student, honestly, you should probably not worry too much about the GPA. That's not super important, but just by the requirements of the university, this is the baseline here. So we do require you to pass 4 qualifying exams as a PhD student. These are 3-hour written exams that are offered well, at the end of the fall semester and the end of the spring semester standard. And the 4 exams, one has to be an algebra one an analysis one, and then the other 2 subjects you get to pick. And so you have to complete basically 2 of these qualifying exams by end of year 2, and then all 4 by end of year 3. So you basically have 3 years to complete these qualifying exams. I should say the qualifying exams, we don't really see them as like a big deal. They're not supposed to be some big hurdle. It just provides kind of one kind of baseline check that you sort of have core competencies in the fundamental areas of mathematics. So it's not supposed to be a big deal, really. But it's a good chance to kind of review and sort of solidify your training in the core areas. And so I should mention that for these algebra 1, analysis 1 qualifying exams, which honestly, these basically cover what you would have, all of you guys, I know your files would have studied as an undergraduate. We actually offer these as placement exams when you enter in September. So if you enroll in the program, I'll be in contact with you by early summer to give you information about these qualifying exams, sort of the syllabi, the handful of previous exams that you can practice on. And I'd really encourage everyone who enters the program to take these exams in September. There's actually 0 downside if you don't. These are all pass-fail exams. There's 0 downside if you don't pass them when you first try them in September. If you do pass them, not only you pass your 2 of these qualifying exams, and you also place out of the corresponding first courses in algebra 1 analysis, which for a lot of you guys probably don't need to take. And also, even if you don't pass them, you get good practice in taking these qualifying exams. They're kind of a very low pressure situation, or a lower pressure situation anyway. You get to practice these exams. So I really recommend everybody, even if you haven't had time to totally prepare, to take these 2 algebra 1 and analysis 1 qualifying exams when you enter in September, shortly after the start of the new semester. Okay, so that's the courses and the qualifying exams. As I mentioned, you also go through very informal TA training, just to kind of get you up to speed with teaching in the classroom in year 1. And then the most important kind of thing you'll do in your first couple of years at Northeastern is to find the PhD advisor. And we ask you to find the advisor by end of year 2. I mean, honestly, you should try to find the advisor as soon as possible. I would say, just kind of general advice, not just our program, any program. Try to find the advisor as soon as possible, even in year 1. And yeah, I mean, you're wondering how that works in our department. I think it's similar to a lot of places. You're not assigned advisors when you come in. It's really kind of a matching process carried out jointly by the students and the faculty. But the way it works is, of course, you talk to your professors in office hours, you attend seminars and meet people in seminars. You are assigned, all of our first year PhD students are assigned a first year faculty mentor, which is kind of like a pre-advisor advisor. There's someone who you can go talk to about if you have questions about coursework or about how to be a PhD student. If you're kind of maybe if we try to sort of match you by interest in mathematics, so someone you can talk to about math, kind of find out what's going on about research. So anyway, so the first year faculty mentor is a great resource. You can also, as you move along, take reading courses or independent study courses with faculty. That's sort of a second step along to sort of finding an advisor. And of course, you can also just just meet a faculty member, tell them you're looking for an advisor, and ask them if they have any projects for students. So find the advisor by end of year 2. And then once you have your advisor and you've taken your courses, passed your qualifying exams, you want to achieve PhD candidacy by end of year 4. And so this basically is you basically do some kind of initial research project type stuff. So basically you do kind of a little 3 and 10 page project reports about your initial research. You can read the descriptions there, but they're basically, you started on your thesis work and you write up either a very short report about what you're doing or kind of a more substantial report that could be sort of a chapter of the thesis or maybe an archive preprint or something like that. And then the final step in achieving candidacy is you give a 1-hour seminar style talk about that work in front of a committee consisting of your advisor and a couple of other faculty members in the department. And the purpose here is really just to give you some practice in-house for giving seminar talks and also of course giving your dissertation defense. And then finally, by the end of you've achieved candidacy by the end of year 4. Year 5, you're not really taking any more math courses. You're just sort of doing formal. You're doing your dissertation research, and then by the end of year 5, by April of year 5, you defend the dissertation in front of your committee, and then you are an official mathematician. So that's the structure. I would say it's just the academic requirements of our PhD program. It's a 5-year program with various kind of hoops. But of course, the main hurdle, to getting a PhD is just doing the doctoral dissertation. That's why you're all here, is to really learn enough about an area of mathematics such that you can do individual original research in that area. And you can have your own theorem. Okay, so to kind of give you a little bit sort of better idea about sort of what courses in the department look like, I thought I would just give you, so the courses that we offer, they range a lot. They change a lot from semester to semester because sort of it depends on what faculty members are teaching that semester, what they want to teach. But I thought I'd just show a sample course mate or a course list from last fall, given that you guys will be entering next fall. So this is just every semester toward the end of, say, the spring semester, we'll send this off to the PhD and master students to advertise all the graduate level course offerings that we'll be offering. So in the fall, last fall, we offered our sort of standard 1 semester introduction to analysis course. We offered an applied linear algebra course. So this is sort of linear algebra sort of at the graduate level, but really with an emphasis on applied mathematics. So for example, applications to numerical analysis, things like that. We offered a pure math algebra 1 course. And for us, the algebra sequence consists of basically algebra 1 is group theory and Galois theory. And then algebra 2, the next semester, is commutative algebra, rings and modules. We had an introduction to mathematical modeling course for this on the applied side. Offered a course in PDE, first course in PDE. Offered a course in numerical analysis, actually numerical analysis 2, so there's a year-long sequence. Offered a course in graph theory. Actually, you'll be hearing from Professor Lipner later today. Course in probability, first semester course in probability. Course in algebraic number theory. I should say, by the way, that we actually do not have any research faculty in number theory. That is one area of mathematics we're not really represented in our department, but we did have one of the teaching faculty teach a course in algebraic number theory, which is, I think, a really for interested students. Course in applied statistics. And then, well, I mean, you should kind of ignore this PhD level stuff. It's all kind of the same. Had a course, basically, the title of the course is Mathematical Methods of Classical Mechanics, but it was really about symplectic geometry course. Had a topics course in algebraic geometry taught by one of our postdocs. That's actually another great benefit of having a robust postdoctoral program, is that our postdocs typically do teach at least one graduate level course when they're here. And so basically they like to teach kind of, courses related to their PhD thesis research. So you get a lot of interesting sort of topics courses from the postdocs. So Vance Blanker has taught a topics course in algebraic geometry about moduli spaces, very interesting subject. Topics course in representation theory about, well, Cohen-Macaulay modules and approximations. I taught a topics course in topology. It was basically about knots and 3 manifolds, so low dimensional topology in dimension 3. And then also we have we run a couple of seminars basically as courses. So in the fall, we run a course called Research Seminar in Mathematics. And so this is a course which basically consists of, it meets once a week on Tuesday afternoons from like 1 to 5. So it's like 4 hours once a week. And then the Professor Weitzman brings in a selection basically of research mathematicians, other professors from basically all over the country to give lectures, to kind of give 3-hour lectures about their work, sort of starting from very introductory for the first hour to sort of a research talk by hour 3. So it's kind of a fun kind of sampler for like basically different areas of mathematics and what's going on in different areas of mathematics. So anyway, so this is just sort of a listing of the sort of things that happen here in the courses for a semester. Okay, so kind of coming to the end here. So the final thing to talk about, I think you should ask about definitely, is sort of what happens to math PhD students after they complete our program. And so here's a little bit of data about our PhD student placement, both what they write their theses in and where they end up after the thesis. So this is just a spreadsheet that we try to maintain about basically what happens to our PhD students. So here's a listing. It's kind of small on that screen here, so maybe just make it a little bit bigger here. A listing of basically of all the students, their advisors, their thesis titles, and then where they ended up after graduation. So the initial placement. And so you see postdocs at Arizona, lecturer at Harvard, postdoc at Pittsburgh, postdoc at HU Berlin, postdoc in Beijing. One of my students basically went to work at a tech company. He's now CEO there in Australia. Postdoc at a basically data analysis at a bioscience company. Of course, Boston, Cambridge is probably the biggest life sciences hub in the United States. So there's actually a lot of our students can go off to do sort of data work there. Technology officer at another Massachusetts startup, postdoc at Virginia Tech, data scientist at Liberty Mutual, postdoc in Beijing, data scientist, postdoc in Göttingen, postdoc at Tsinghua, postdoc at UC Davis, data analysis, tech. So basically, I would say there's basically a 50-50 breakdown for our students of basically ending up going to sort of the academic postdoctoral route. I'd say we're quite successful for a department of our size of placing our students in postdocs, as well as of course, a lot of students going off into the tech arena in one way or the other. So here's some more placements, and then basically we just kind of don't have the data. When we started collecting this, there's kind of a big gap in the data after 2014. We just don't have this data, but basically there's a remaining list of basically, you can see basically a historical kind of log of the department based upon the PhD theses produced by the department. I think that's actually a really interesting way to think about the department, as sort of the function of the math department as a sort of system for producing PhD theses, and kind of to give you a picture of the department there. So I'll make these slides available to you, and it might be kind of fun to go back and look through all the thesis titles with the advisors in history. I certainly found it interesting to look at. Okay, so anyway, so that's sort of what I have to tell you. I definitely want to leave time for questions, but I congratulations to all of you who are here, and I hope to see you at Northeastern in the fall. Okay, so I'm going to stop the recording.